All right, we are looking at your concept quiz 6. So if you're here, hopefully you're studying and getting all ready. Let's see what we can do. So we're looking at this function. The first thing we need to find is the roots. Well, if you recall, that means you have to plug in 0 for the y value. F of x is the same thing. And then we end up getting this. The first rule of factoring is to take out a common factor, but in fact I only have one x thing, so I'm going to do it both ways. So I'll show you how we can do if we take out the common factor. If we can take out the common factor, we get this. So when I divide by 15, those go because 0 divided by 15 is 0. And then I get x plus 2, x minus 2. So I have to then set them equal to 0. And I get my two answers. Okay, we'll put them in there, and then I want to show you the other way, just for the sheer joy of doing mathematics, people. My other option is that this is just one x term. So I'm always trying to isolate the x term. So I could just add my 60 over here. And then I could divide by 15. And I could get that x squared is equal to 4. And then I could undo my square and get plus or minus 2. Either way, I get plus or minus 2, so those are my roots. Sketching its graph, we do need to have one additional point. So I do know that my vertex needs to be somewhere on this line. So I want to plug in a 0 for x. And when I plug in a 0 for x, oh my lands, I get a negative 60 for y. So this point would be 0, negative 60. So that is my sketch of my graph using the 0 value. So let's look at this one here. This one says which set of points represents the x-intercepts of the function. So same story. It's all the same thing. X-intercepts means that y is 0. So we do need to factor this. Now factoring this, there is no common factor, so I just need to go ahead and do my little diamond problem here. Multiply the front and the back. So then I get, what, 6 and 4? Negative 6 and 4. Okay? Remember, these are what you're using to rewrite it. Now, if you have a factoring that you do another way and you end up with the same answer, all is good, people. There are so many very nice ways of factoring, and if you have a way that's working for you, there is no reason to change. But this is a concept that works every single time, and it's nice to have in your little tool belt. The next thing that we do is we look at these two terms to find out what's common. 4x, hopefully you see it. You left with 2x minus a 1. The whole thing came out. 4x over 4x is 1. You then look at this next part. You hopefully see that there is a negative in both of them, so we're going to pull out a negative 3. You're left with 2x plus 1. Now that is good, people, because if these are exactly the same, then those get pulled out of both of them, becoming a factor, and your leftovers become the other factor when you put them in the same guy there. So this is what we have, and we need to actually solve for that, because remember we set it equal to 0. So be careful. I'm glad you're here and looking at this, because many students get a pattern that it's always just the opposite of in here. And in fact, when we did this one here, it was just the opposite. But that was because there was nothing in front here. The rule is, which is why I showed you this, is you have to set it equal to 0. And in this case here, when we set this equal to 0, I do not get negative 1 as my answer. What I get as my answer is negative 1/2. So you do need to set it equal to 0, or at least understand that concept, so that you're not just taking the opposite of it, because it just doesn't work that way. So those are my two answers, here and here. And of course the proof would be in the factoring of it. Or your proof could be that you take these values and plug them in. And you would say that if I plugged in 3/4 in here, and 3/4 in here, and solved it, and you would show all of your work, which I don't want to do because those are Ricky fractions, but you could do it, you would end up getting that 0 is equal to 0, and you could check it. Then you would also need to plug that one in there. So in my opinion, I'd rather just factor it. But absolutely, you could plug them in as long as all of that ended up really equaling 0. Then that actually would work as a proof as well. All right, we're on to our last one. Actually, I'm going to turn the light on. Look at that. It's like bright in here now. Okay, so we have 1, 2, 3, 4 little situations here, and we need to figure out which ones have 0 real roots, 1 real root, and 2 real roots. So I want to make just a quick little sketch of each of them. So my f of x sketch is going to be 0, 0 is my vertex, and it's going down. So that would be an example of 1 real root. I just want to do all of them just so I can make sure I know where they're all going to go. This would be, my vertex would be -1, -2. Remember, this was 0, 0, and again it was going down. This is -1, -2 here, and then I need to have a 1/3 but positive, so it's going to be going up like this, so that would be 2. And then this one here would be at h of x is at 0 for the x and 5 for the y, so way up here, but it is going down. So this one is also 2, so that's another choice that I have. And then this one here is 1, 2, 3, 1, 2, 3, 4. So again, k of x is equal to the 3, 4 for the vertex. Whoops, I ran out of space. There we go. And so then I also have it going up. It's positive. So we've got this situation here. So this one here is 0 real roots. So we're going to say k of x. And then we'll show our little sketch of 1, 2, 3, 1, 2, 3, 4, and our little sketch. So that is definitely enough proof for it. For this one here, we're looking at the 1 real root, which is this situation here. We only have 1 of them. So that's our f of x, and our picture was there was the vertex. It was going down like that, and that is only 1 real root. And then our last one is 2. There's 2 of them. There's the g of x here, and there's also the h of x. So the g of x went over, where was that? -1, -2. We had a little situation there. That's the g of x, and then the h of x, we had 1, 2, 3, 4, 5 going down because it is negative, and so we also have the 2 there. So in both of those situations here, we have 2 real roots. Thanks for playing. Hopefully you'll do really well on your quiz. Good luck.